Hi, everyone. My name is Sheila Russo, and I'm thrilled to be here with you today to give you a sneak peek, I would say, into the research that we do in my lab, the Material Robotics Lab here at BU, and specifically talking about soft material robotics and the next generation surgical robots. So in my lab, we are aiming at tackling open societal challenges in healthcare. Specifically, we're manufacturing, designing, working on the hardware side really of robotics to develop robots that can guarantee high quality healthcare. This means improving surgical procedures that are currently possible to perform, but by making them easier to perform, more intuitive, and also enabling novel surgical procedures that are not possible to perform today. We are also developing robotic solutions that are low cost, made out of easily accessible materials that are disposable or have very low cost of sterilizations, that are easy to transport to address healthcare inequality challenges. The clinical applications that I'm showing here, especially in interventional endoscopy, minimal invasive surgery, are great case studies to enable us to tackle open robotics challenges as well. And so specifically, we are targeting how do we achieve robotic navigation in complex and unstructured environments? What is more complex, than navigating inside the human body? How do we achieve robotic manipulation and grasping of fragile and delicate objects? So think about human tissues, human organs, and how to achieve safe actuation and safe sensing in robots that also need to have effective force transmission when they are interacting with humans. And in this case, in very close contact with humans, literally inside the human body. So I don't have a lot of time today, so I will only be focusing on a couple of projects that we're working on, but I would be very happy to connect with you afterwards or reach out to me over email. The first project that I want to talk about is a soft surgical robot that we have been developing for interventional pulmonology. So this is early stage lung cancer diagnosis and treatment. Lung cancer is the deadliest form of cancer. It kills more patients than prostate, breast, and colorectal cancer combined. This robot is the smallest and most flexible surgical bronchoscope, and so robotic bronchoscope. And so this means that it can access deeper locations within the lungs where lung cancer can remain undetected. Please consider that approximately 70% of lung cancer nodules are forming within the periphery of the lung, where it is difficult to navigate. This is a project in collaboration with Boston Medical Center, BMC, and I also want to acknowledge our funding up there. I also want to briefly highlight a project that we have been working on for soft robots for interventional colonoscopy, specifically helping to diagnose colorectal cancer and treat colorectal cancer. Colon cancer is the most common type of cancer in both men and women. However, not everywhere in the world people have easy access to colonoscopy screening and anesthesia. And so in my lab, we have been developing soft robotic solutions, specifically soft sensing, to enable safer, more gentle colonoscopy procedures. That entails, for example, developing sensors that can detect bleeding or excessive force transmission, excessive forces during colonoscopy procedures to prevent severe adverse events post-procedure. This is also a collaborative project with Harvard Medical School and funded by NIH. In this framework, we have been developing a variety of solutions, soft robotic solutions to, for example, restore haptic feedback for surgeons during minimal invasive surgical procedures, so through wearable robotic devices, as well as developing novel ways to improve navigation in robots and grasping and manipulation via soft shape sensors and optical sensors. I also briefly want to say that these projects actually blossomed from the integration between research and education from my lab into the graduate course that I developed here at BU, Medical Robotics, where students learn to identify a medical challenge and engineer a robotic solution to it. Thank you so much.